thank you very much. So first and foremost, I'd like to take a moment just to thank Rescale for hosting this event, and also thank our AV crew in the back, as well as all the servers that we've had here for a great evening and for all the hard work they do. So if we could take a moment just to thank them. So what I'd like to do is kind of just take a few moments to walk you through kind of the AMD view of how we see meeting the demands of the modern data center. Certainly this has probably been a long, fun, exhausting week for all of us, especially at this time of night, having to listen to me up here for a few minutes. But I appreciate your patience. Afterwards, if anybody has questions, I'm happy to speak out in the hallway. So, we'll make sure everybody sees that. Okay, forward-looking statement. All right, we're good. So, one of the jobs that my team has, and myself and my team has, is we have to kind of branch predict where we see things going into the future, right? So our job is to see what customer use cases look like, what the hardware technology, the software technology looks like, and then how we map and meet those demands. So, as we kind of look out towards the 2030 timeframe, one of the exercises we do frequently is we talk about these future computing scenarios, right? And we've touched on a bunch of these already across the board, whether it be on personalized medicine, whether it be talking about deeper perception, simulation, and weather, from a weather standpoint, smarter, more inclusive AI. Enhancing our user experiences, I think that's a big piece of it. How many of us, if we even go today from a user experience, go to McDonald's now and you walk up to a kiosk and you order your Big Mac and fries, touch of a screen. Or in my case, I drive a huge transit van with all the kids loaded in the back, already loaded it up on my phone, hit I'm here, and they bring all this food out to me, up to my window. It's a little bit more convenient. But that's enhancing our experiences and what we expect whenever we go to places. Another big part of this is kind of the data-driven business innovations. So, on this area in particular, I think about what we've just gone through over the past couple years with COVID, with the COVID pandemic, also with things around supply chain constraints. So, into the future, that data-driven business innovation is going to be critical to making sure that we can keep, secure supply chains and keep the wheels moving. So things like, being able to understand that whenever a ship is blocked coming into port, in the port of San Francisco, what does that mean in days of delay and time to market of product showing up on a shelf, or even if you're ordering from Amazon standpoint or anywhere else, time to it gets to your door, right? So how do we kind of use that data to better predict that? Or in some cases, actually react in real time. You find out that there's an issue with the road, there's construction that happens, there's going to be a delay. I can now in real time update you. I mean, I'm sure all of us have been through the process of, the U.S. Postal Service, love them, thank you for all you do. But, we see that our package is arriving on Tuesday. Friday afternoon, we're driving downtown to go pick it up because we didn't have the real-time information coming back to know that there was a delay, right? It's frustrating. But in the future, we're going to be able to track an even better analytics than we already do today, kind of where that is in real time. And then we also know that sustainability and efficiency is going to be critical into the future. And then another big piece of this, and something that the Rescale platform and cloud computing is especially important about, is this idea of this subscription-driven economy, right? Being able to get access to the hardware, software, and services resources when I need it, but only for how long I need it, and not pay for things to sit around idle in a data center somewhere. So that's going to be really critical in the future. And then, of course, I'd be remiss if I wasn't to say about data sovereignty and security, especially given, just everything kind of going on in a geopolitical climate. Security is going to be even more crucial to everything that we do. So, at AMD, we kind of look at this to solve this problem is, what are the technology requirements then? If we have that future computing scenario, how do we meet that from a technology standpoint? Well, we've touched on a lot of these already. So first and foremost, we view everything as being high performance. We are at an HPC conference, by the way. We probably think that's a little bit of an important facet there. But high performance also coupled with efficiency. So making sure that what we're deploying is getting the best performance per dollar, performance per watt in our data centers to make use of the space that we already have. And we talked a lot about this. For decades, we've heard about, the idea of, optimized, architectures coming along, domain-specific accelerators being put into the pipeline and co-integrated with all the systems that we deploy. I think we're finally there. Whether it's ranging from CPUs and GPUs and FPGAs being deployed next to each other to SmartNICs being put into the middle of a data processing pipeline, we now are at the standpoint where having that full optimized set of different hardware features is really going to allow us to move forward. The software ecosystem is crucial. I'll touch on, a little bit of some of the innovations we've been doing as a company, but without software, let's face it, the hardware is a really expensive space heater to sit around in a data center. And software is usually the number one barrier to adoption, successful adoption of new novel hardware architectures. So that's going to be extremely critical. And then, of course, security and networking. For those of you that have been at this conference, you may have heard about the announcement of the Ultra Ethernet Consortium. If you have not, I recommend you check that out, either by looking online or stopping by the booth before the end of the conference. But this is a collaboration across some of the industry's biggest players in the cloud and the OEM and the silicon space and networking space to look at making Ethernet truly, bring a standard forward that will allow Ethernet to truly be performant for both AI and HPC use cases. So definitely recommend you check that out. And so a lot of what we're already looking at here in these technology trends, AI truly has transformed everything we're doing overnight. We look at the fact of, and I think the gentleman from Intel was talking about the doubling of Moore's Law, right? Doubling of Moore's Law was roughly about a 24-month process that we were seeing this increase in compute. AI is causing that to be a 3 to 4 month need of increase in compute capacity just to keep up with the explosion that we're having around AI. And that's not sustainable. That's going to be a challenge. We also look at where leading supercomputer performance has gone. So we look over from 1990 out the next couple decades. It took us a little bit of time to get to a petaflop, but look at the acceleration of time from a petaflop to an exaflop and beyond. It's rapidly increasing. And of course, a lot of that is driven by not only the enhances in the density of CPU architectures, but also GPUs and what they're bringing to the table, and then the fact that our networking speeds and data volumes are just going through the roof. And then we look at AI memory. AI memory is going to be a very big bottleneck across the board. These large language models are just getting bigger and bigger, and so we're going to have more and more pressures across the way that we build systems. The cost of those systems, as the cost of DRAM continues to go up in next generation hardware, we're going to have to be looking for different ways to solve this. And one of the final things I wanted to kind of leave you with before talk about how we're working to solve these challenges is, data center demands are stressing our capabilities. So, we're at a conference where we're talking about power, space, and cooling an awful lot, whether that is in the cloud and as a cloud provider and everything they have to do on the back end to hide that from you. It's a lot of work. If you've never seen the space planning that the cloud providers go through, it's incredible what they do. Or if you've been in the, I can say lucky or not so lucky, place of having to build your own data center or manage your own data center, those come with many headaches. That there's a lot of lead time, there's a lot of capacity planning, and it's really hard to make a decision today to help you prepare for the next 3 years, because we saw that overnight, everybody's seeing ChatGPT, and there's just this explosion of excitement around AI that everybody's racing for it. You don't build that kind of capacity immediately. And then we're at this inflection point where we've also been slowed down by everything that kind of happened during COVID. So we were already kind of stressed before we got to the point of the COVID pandemic. And then, bringing that tech debt along. And then we have the pandemic, we have supply constraints. We can't travel to fix these data centers, to build new data centers. It's very difficult. So we're at this perfect storm. And it's been interesting. I get a chance to go talk to a lot of colo providers. And one major colo provider we were talking with said between now and the end of 2024, all of their facilities in the United States, the maximum capacity they have left is 3 megawatts. That's it. In 2024, their buildings will open, but they're already being bought up in 10 megawatt chunks before the concrete's even dry. So you can kind of see where this is going and why planning for the future is going to be important. So, from an AMD-centric standpoint and really the industry standpoint, we see that heterogeneous computing is where we're going into the future. Everything from utilizing general purpose compute infrastructure to adaptive SoCs and FPGAs, accelerators, custom SoCs, and even custom ASICs. So the whole way from highly adaptive to highly specialized and customized hardware. And so we view this as really helping us kind of get through a couple different important steps. First and foremost, it's going to address efficiency, right? Critical to meet the sustainability goals and create space and capacity. So I just walked us through a little bit of those challenges and talked about those data centers and how stressed they are. If you look at where legacy IT workloads are at, the amount of space, power, and cooling that they're using that could be freed up by going to denser platforms, better consolidation, utilization, even in the HPC standpoint, is going to be crucial to be able to open the way to deploy these AI power-hungry, cooling challenged GPUs alongside that traditional HPC in your data center. So a lot of times what we like to tell customers is you have more capacity to lead and innovate today in your own data center or by partnering with your cloud providers or colo providers that already exist, simply by making sure that you're making efficient choices in the architectures that you're choosing going forward. We also see performance being critical to this, right? Nobody wants to go through and buy the latest and greatest hardware just for it to underperform on a past generation. Otherwise, our stock's going to tank. We're not going to be in a good place, and I'm going to be looking around for my next gig. So we want performance to be a very crucial piece of what we do going forward. But what that also means is it's not only these co-design or these heterogeneous architectures from a hardware standpoint, but it's the software. So true software hardware co-design is going to be crucial going forward on the next generation. And we see where that's going to apply across all the different big business segments. Of course, with generative AI, and we see where that's going, autonomous driving, smart cities, and we touched on a lot about biomedical research. And I was glad to hear so many different times healthcare getting mentioned, because I think that's so crucial going forward. And then at AMD, we also view innovation as being a big part of the strategy of how we're going to help meet the demand. So first and foremost is, leading in our chiplet architecture. So, we're the first in the industry to release a 3D stacking of chiplets, which allowed us to introduce some of our higher L3 V-cache products in the latest generation of processors, and also opening the way to to mix and matching different chiplet architectures. So there's an industry standard called UCIe that is also currently active across the industry, that is being positioned best to allow you to even bring custom chiplets to be able to plugged in and integrated alongside commodity x86 infrastructure or other architectures, so you can truly specialize the hardware that you need. When I talk about that advantage in chiplet packaging, so this is just a quick snapshot of our latest generation EPYC processor series. So all of the processors, there's 4 processors listed on here family-wise. They're all based on our AMD Genoa processor platform. It's the same instruction sets across all of these. It is the same type of core across all of them. Full compatible software stack is fully compatible across all of them. What we did is, using our chiplet architecture that we have, we made some minor tweaks to cache levels or to power levels and peak frequency levels. And what that allowed us to do is kind of expand out that one-time innovation that we did in Genoa and get some more workload-specific offerings. So Genoa X being really built towards that technical computing, large L3 cache type of support. Bergamo, which is actually, and I think I pronounced that correctly, although if I have any Italian friends in here, feel free to correct me on that. Bergamo is really about the highest throughput and density, right? And really, we look at this as being not only there's a lot of high throughput computing applications and densification applications in the HPC space, but then when we think about AI, the cloud native space and the fact that containerization is just going to be prolific throughout that whole industry. And then last but not least, we just released our Sienna platform, which is a single socket platform really co-designed for edge computing use cases. So again, thinking about how we take one technology innovation and stretch that farther in order to get value to be able to handle the entire spectrum. We also have the upcoming release, if you haven't seen in the public, about our upcoming AMD Instinct line. We have 2 different product lines that are coming out of this. The first one is the world's first ever APU. The MI300A is what we call it, and that is basically a co-packaging of AMD EPYC processor and a cache coherent packaging in our Instinct processors in the back end. This is the same type of product that is actually being purpose-built for HPC applications and going to be going into the El Capitan exascale computer and is actually currently being installed as we speak. It's really, like I said, it's really purpose-built from an HPC standpoint. And then we also look out to the AI space, and this is where we introduce our MI300X series, which is an OAM-based platform. And this is really targeted at those, scaling to meet the largest demands of those memory-hungry large language models I was talking about. So you can look at the fact that we have 192 gigs of HBM3 on board on these GPUs. So again, it's about feeding these power-hungry GPUs, loading the largest models up on a GPU we can, processing it quickly, and then moving on with those. I also wanted to quickly touch on, execution is another big piece of how we look at AMD strategy. So, if you look at our journey that AMD has had over the last couple years, from really the reintroduction of our AMD EPYC processor line with AMD Naples, the whole way out to where we are with today with Genoa, it is about clear communication, clear execution, and clear delivery. And that same process is a part of our Instinct product line as well. So you're going to see that same method, that same cadence being continued across the board with AMD Instinct product as well. And then last but not least, and why this is so critical for partners like Rescale, our cloud partners, and other OEM and software ecosystem partners, is we have to make it easy. If we look across the board, the time it takes to take a piece of hardware, order it, bring it into your data center, rack it and stack it, provision it, deploy a hardware stack, there's a lot of lead time with that. And specifically for a company like AMD, whenever we're fighting hard to not only grow our business, but maintain our business that we have, getting access of our latest hardware and software technologies out to the end user and to our customers is crucial. And so when we look at the innovation that we have with Rescale, specifically around the deployment of AMD Cloud Labs, this is even more critical. How can we have customers go in with a couple clicks of a button, spin up an entire end-to-end software stack, and get access to be able to run their codes and test through our platforms seamlessly? And so with that, what I'd like to do is show two brief videos that the Rescale folks have shared with me as well. And then after that, like I said, I'll be available for any questions or comments afterwards. But before I show those videos, just thank you again to Rescale for having us. I hope everybody enjoyed themselves. Have a good rest of your night, and also please have a safe trip home.
How do you know the best way to run your simulations? There's more specialized hardware than ever before. With AMD Cloud Labs on Rescale, you can compare high-performance architectures at a glance and quickly pinpoint the best possible option for your budget. Try the platform today. New ideas need to be tested. Cloud high-performance computing can help, running simulations quickly and securely. But preparing the required infrastructure can be a lot. AMD Cloud Labs on Rescale shortens your to-do list to a few clicks, so you can bring your ideas to life. Get started today.
All right, thank you.